Welcome to Stone Game 9. Alice and Bob take turns removing any stone from the list. They track the sum of removed values. The player who makes that sum divisible by 3 loses. Alice starts first. If no stones remain, Bob wins automatically. Return true if Alice wins with optimal play. Tip: you lose on your move if the sum becomes divisible by 3. Only modulo 3 matters. Reduce every stone to remainder 0, 1, or 2 and count how many of each. Call them C0, C1, and C2. Why? Whether the sum is divisible by 3 depends only on remainders. Tip: 4 becomes 1, 5 becomes 2, 6 becomes 0. Play the game on 3 piles of remainders. How moves change the sum? A type 0 stone keeps the current remainder the same but uses a turn. A type 1 stone adds 1 to the remainder modulo 3. A type 2 stone adds 2 to the remainder modulo 3. Tip: type 0 stones are turn flippers. Types 1 and 2 change the remainder. Alice's opening choice. She cannot start with a type 0 stone because the sum would already be divisible by 3 and she would lose instantly. So she must open with a type 1 or a type 2 stone. Those create 2 branches of the game. Alice picks the branch that wins if either one works. Here is the winning formula. If C0 is even, Alice wins when both C1 and C2 are greater than 0. If C0 is odd, Alice wins when the absolute difference of C1 and C2 is greater than 2. Tip: this collapses the whole game tree into one simple check. Examples: stones 2 and 1, remainders 1 and 2, C0 is even, both types exist. Alice wins, return true. Stones just 2, only type 2, min of counts is 0, Alice loses, return false. Stones 5, 1, 2, 4, 3. Remainders give C0 equals 1, odd, and C1 equals C2 equals 2, difference 0, not greater than 2, return false. Algorithm recipe. Make a count array of size 3. For each stone, add 1 to count at stone modulo 3. If count 0 is even, return whether count 1 and count 2 are both greater than 0. Otherwise, return whether the absolute difference of count 1 and count 2 is greater than 2. No game simulation needed. In JavaScript, count remainders into an array of 3 zeros. If count at 0 is even, return whether the minimum of count 1 and count 2 is greater than 0. Else return whether the absolute difference of count 1 and count 2 is greater than 2. Tip: minimum greater than 0 means both types exist. Tiny code, big insight. Time is O of n for one counting pass. Space is O of 1 with 3 counters. Edge case: if there are no type 1 and no type 2 stones, Alice cannot open safely. So Bob wins. Key takeaway: Stone Game 9 equals count mods. Even C0 needs both 1 and 2. Odd C0 needs absolute difference greater than 2.